Welcome to our final lesson in our multi-step packet. This is lesson 11, and we're going to identify the type of solution upon inspection, and that means by looking at it. Our goal: I can identify whether an equation has one, no, or infinite solutions before I solve it based on the characteristics of the equation. We can actually identify whether an equation has one solution, no solution, or infinite solutions before we solve it by identifying certain characteristics of each type. So let's see if we can identify similarities and possible differences in the following group of equations. So we're going to start by looking at the infinite solutions because I think that is perhaps the easiest. So I'd like for you to highlight the terms that have the same variable. So I have 3x and 3x. They're both the same. And if I highlight the constant, those are both identical. So it would make logical sense if both sides of the equation are exactly the same. No matter what x value we choose, both sides will still remain equal. So now let's look at the equation below it. I see 6x, a group of variables, and they switched the order, but I still have a positive 6x on this side. So those are identical even though the order is switched. The constant, I see minus 8, and I see negative 8, and mathematically those are identical as well. So even in this next equation, they don't visually look identical, but we can see that the constant is the same and the term with the variable is also the same. So let's write down those characteristics. So the term with the variable, the terms with the variable are the same. So that's one of the things we noticed. And the constants are the same. I'm going to underline that. So we're noticing that everything's the same. So now let's go on to no solution. So as I inspect or look at these two, I notice that the term with the variable on both sides is the same. And now when I look at the constants, I can see that I have a positive 7. However, on the other side, I have a negative 2. So this first example, the terms with the variables are the same, the constants are not. Let's see if that happens again in the next example. So here's the term with the variable, it's a negative 5x, and on this side it's also negative 5x. And then I see that I have a positive 6 and I have a negative 10. So the constants are different. What I want to make sure you don't assume is because one is positive and both of these examples have a positive and a negative. This could have been a positive 7 and a positive 2, but the fact is they're different. That's what's important. So let's write down those characteristics. So what's important for this is that the terms with, and I'll spell it this time, the variable are both the same. So again, we have that both the same. Now, the constants, however, the constants are different. And that's very important because that's what's going to keep it from being like an infinite solution. So let's go ahead and underline that again. Let's decide that we want to make sure that we're clear on that we have the terms with the variables are the same, so that's just like infinite, but the constants are different. Now let's go on and look at what we see comparatively to what we've talked about here for the one solution examples. So let's look at the term with the variables. I see 5x, and when I look on the other side, oh, this is a different term. Okay, in our other two examples, both of the terms with the variables were the same. In this case, I have 5x and 2x. And now let's look at the constants. Maybe they're the same. If I look at this first constant, it's negative 23. And if I look at the second constant, it's negative 5. So every part is different. I wonder if that happens again when we look at the second example. So let's look at our first term on this side. And sure enough, the term on the other side with the variable is different. If I look at our constants, I have a positive 6, but then I also have a negative 10. So all of the parts of this are different. So the most important part of this is that the terms with the variables are different. And you might be saying to yourself, well, gosh, the constants were different too. But that's not important here. And let me use the first example to show you why. If we're given 5x minus 23, and we had 2x, but this constant was the same, 23, here's what would happen if we solved it. We would get rid of the weakest term, or one of the x terms, it doesn't have to be the weakest, and we'd have 3x minus 23. And on this side, we'd have negative 23 because this would eliminate. Then we continue to solve by adding 23 on both sides. You do not have to copy this down, by the way. And then I'd have 3x equals 0. And then I would divide by 3 on both sides, and x would equal 0. Now, 0 is a solution. It is one solution, and it means that if this would be true if 5 times 0 minus 23 and 2 times 0 and minus 23 were on each side, they would both be equal. It would both be equal to negative 23. And this one solution, meaning x equals 0, would work. That's the only solution that would make this true. So this is a proof of why we only need to worry about, we only need to focus on the fact that the term with the variables are different. Okay? Now, speaking of which, let's go. Oh, I just happened to use the same number. So now I'm going to do my second solving step, which is I'm going to add 23 to both sides. And I would have 3x equals 18. And to solve the last, I would divide by 3, and I get a solution of x equals 6. Well, down below, we got x equals 0. And with the equation where I changed this number to 23, 0 is a solution. It's one solution. And here, this is the only one solution. And that is caused by the fact that the terms are different. It does not matter about the constants. Let's see what happens now if we solve the next. We're supposed to get no solution. And let's see if we do. If I took away the term with the variable, they're the same. So I'm going to get a solution already that says 7 equals negative 2. And that's not true. That's a nonsense. 7 does not equal negative 2. And so there's no answer for x. I cannot find a number for x that I could replace where x is and make this true because both sides started out differently. Let's look at the final. If I tried to solve the infinite solution one, if I were asked to solve instead of just inspect it, if I started out by getting rid of variable on one side, what would happen is both variables on both sides would cancel out like they did in the no solution. But I'm going to be left with 7 equals 7, and that's true. And so that means, once again, since both sides are identical, then no matter what value I put in where x is, it would make the equation be equal to each other. Where this one, on no solution, I'm never going to be able to find something to replace x with that would result in equal numbers on both sides. And this will always give it to me. And when you work with one solution, there's only one possible number that will solve this. So now turn to the back page, please. See if you can use the characteristics we've listed for each type of solution, one, no, and infinite, without actually solving the equations. This is called upon inspection, meaning we're just looking and analyzing the characteristics. Place the number of the equation in the correct column. So I'm going to do 2 with you, and I'm going to ask you to try the rest on your own. So the first place I'm going to ask you to start is always by looking at the terms with the variable. Okay, I see 12x and 10x, so I'm going to go ahead and highlight that. I see 12x, and that's different than 10x. So before I look at the constants, I actually don't need to look at the constants because I know that equation number 1, because the coefficients are different, coefficients with the variables are different, I'm going to get one solution. So it belongs in the one solution group. Now let's look at the next one. I see this equation and this equation. Again, I'm going to start with, I'm always starting with the term that has the variable. Whoops. I see negative 3a and I see negative 3a. Oh, they're identical. And that means automatically it's no longer one solution. It has to either be one, no solution, or infinite solutions. So now I do need to look at my constants. I'm going to look at them and I see that I have a positive 8 here, but I have a negative 6 here, and they're different. If they're identical, if everything's the same, it's infinite solutions, but if the constants are different, then it's no solution. So I'm going to say equation number 2 belongs in this column. And so you're going to do that using your characteristics, and always start with the term that has the variable. Thank you for watching and have a great day. Bye-bye.